Hi, welcome back to my channel. And for today's video, we will be talking about the Eisenstein Criterion. Anong ibig sabihin nito? This actually a theorem that would provide you a sufficient condition. Sufficient condition siya for a polynomial with integer coefficient to be irreducible over the set of rational numbers. So basically, magagamit mo tong theorem na ito for a polynomial with integer coefficient. Okay, so this is just sufficient condition. Okay, this theorem is actually in honor of Gotthold Eisenstein. I don't know if I pronounce it correctly, but hindi naman daw sa kanya lahat tong work na ito. This is in fact alongside with Theodor Schunemann. Pero mas famous ata na ginamit si Eisenstein. Kaya if you notice in some book reference, they use the word Schunemann-Eisenstein Criterion or just Eisenstein Criterion. So here is the theorem for the Eisenstein Criterion. It says here that your D here is a unique factorization domain. So that's a requirement with quotient field F. Okay, so let's take note of that. Yan. And your degree of F is greater than or equal to 1. So, and P here is an irreducible polynomial of D such that your P does not divides AN, but it divides AI for all I from 0 to n minus 1. So in this case, your P squared does not divide A sub 0. If these conditions are satisfied, then F is irreducible in F square bracket X. So if F is primitive, then F is irreducible in D square bracket X. So this is actually in connection with the previous video for the polynomials in unique factorization domain. So in this case, nakafocus lang tayo kay Eisenstein Criterion. Okay, so let's consider first an example for that bago natin i-prove. So let's say your F here is 2x to the 5 plus 6x to the 4 minus 9x squared minus 15. So this is in Z square bracket X. So polynomials in Z na yan ha. So how do we do that? So let P be equal to 3. Then, alam natin that your P does not divides 2. So hindi siya nagdi-divide sa first, but your P divides 6, 0, and negative 9, as well as negative 15 and 0. But when you square the P, so the P squared here does not divides negative 15, tama? P squared here is 9, and it does not divides negative 15. So therefore, by Eisenstein Criterion, F is irreducible over Q square bracket X. Moreover, your G, CD of 2, 6, negative 9, negative 15, kung titingnan mo, yung GCD niya is 1, which is the content of F, tama? So according to the previous video on how to solve the content, in this case, F here is primitive. Therefore, F here is irreducible over Z square bracket X. So that's how we use the Eisenstein Criterion. So ibig sabihin, you'd have to double check first this one. And you consider a P. Your P here is an irreducible element sa D mo. Tapos yung P na yun, you have to make sure na hindi siya nagdi-divides nito, pero nagdi-divide siya sa mga next nila. And if you square this, hindi siya nagdi-divide sa term na ito. So if these things are satisfied, then your polynomial F is irreducible over in Q square bracket Z. Okay, let's have another example. So let's say your F here of X is X to the 5 plus 9x to the 4 plus 12x squared plus 6. So they are element of Z square bracket X. Remember, this is just a subset of Q square bracket X. Okay, so the question is, irreducible ba to siya over Q or not? Okay, let's consider P equals 3. So in this case, P here is an irreducible element, of course. So in this case, P does not divide 1. Bali, ito yung first coefficient niya. But, does not divide 1. But P divides first 9, P divides 12, and P divides 6. Pero when you square the P, so the square of P is 9, no? So P squared does not divide 6. So therefore, by Eisenstein Criterion, this guy here is irreducible over Q. So let's prove this one. So we write F equals the content of F times F1. Okay, in this case here, your F1 is primitive. In, saan siya primitive? In D, square bracket X. And remember, your D is a subset of F square bracket X. Now, remember that the content of F, since the content of F is a unit in F square bracket X, so ibig sabihin the units in F square bracket X being sure tayo precisely the non-zero constant polynomial, yan, it is sufficient to prove the irreducibility of F1 in F square bracket X. Now, since F1 is primitive, alam natin that F1 is primitive, so it is enough to show by the previous video, it is enough to show that F1 is irreducible in D square bracket X. Ito na lang yung ipapakita natin. F1 is reducible in D square bracket X. Okay, how to show that? So let's assume otherwise na hindi. Suppose F1 is not irreducible in D square bracket X. So anong implication nito? In this case, we can write F1 equals GH. Tama? Hindi siya irreducible. So therefore, you can factor that out such that G and H here are element of D square bracket X. And neither a unit. So, we write your G here equals BR, X to the R, plus up to B sub 0, element ni D square bracket X. And in this case, the degree of G is R. Also, we can write H equals, let's say I'll write this as CS, X to the S plus up until C sub 0. This is element of D square bracket X. And so the degree of H here in this case is S. Okay. Now, remember, your F1 is written in G times H. So let's assume that your F1 as a polynomial can be written as well in this form. AI asterisk X to the I. In this case, your I is from 0 to N, where your CF, AI asterisk is AI. Yan. Now, since ito, alam natin to, the content of F is a unit in F square bracket X. Ibig sabihin yan, your AI asterisk satisfies the divisibility condition. Okay, in this case, as AI, so in this case, let's say we can write this as P divides AI, if and only if P divides AI asterisk. Hence, your P here divides the A sub 0 asterisk, A sub 1 asterisk, and up until A sub n minus 1 asterisk. But in this case, your P here does not divide an asterisk. And if you square P squared, that does not divide the A sub 0 asterisk. Ito siya, mangyayari lamang ito if and only if P divides A sub 0, A1 up to AN minus 1, and P does not divide AN, and P squared does not divide A sub 0. Now, anong mangyayari? P divides A sub 0, this implies that there exists, let's say, gamit tayo ng ibang letter, let's say B, in D, such that PB is equal to A sub 0. And remember your A sub 0, that's the same as the content of F times A sub 0 asterisk. Also, your P divides A sub 0 asterisk. That implies P divides B sub 0, C sub 0, which implies either P divides B sub 0 or P divides C sub 0. But not both, of course. This is because P squared does not divide A sub 0. Asterisk. Let's assume without loss of generality. Assume P divides B sub 0 and P does not divide C sub 0. Let's assume also that P divides BI. This is for some. For I, any ranges from 1 to T minus 1. But your P does not divide B sub T. Okay. This is for some T less than or equal to R. Since pwede siyang mangyari since P does not divide F1. Let's consider this one. AT asterisk. So this is the same as B sub 0 CT plus B sub 1 CT minus 1 plus up until BT C sub 0. Your T here is less than or equal to R, but your R is less than N. And your P divides B0, B1 up to BT minus 1. And in this case, your P divides A asterisk since your T is less than N. This implies your P divides BT C sub 0, which implies P divides BT or P divides C sub 0. This is a contradiction since bakit? P does not divide C sub 0 asterisk. So dahil contradiction siya, therefore, F1 here is irreducible in D square bracket X. And hence, your F1 is irreducible in F square bracket X. So, we prove the claim now. So, in this case, your F here is primitive. So, nag-imply that yung content ni F is unit, tama? And so, dahil primitive siya and the content of F is a unit, we can write F equals U times F1. Your F1 is primitive. So, in this case, F is irreducible. That's it. So, if you have question, please let me know. And that's all for this video. So thank you so much for watching. So if you have any questions or clarification, you can comment down there so we can discuss on these clarifications. And of course, I would love to encourage you to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon regarding on discussions of mathematics as well as the research journey. Thank you and have a great day.